access the computer. Sharing screen. Let me know if you're seeing it.
Kita na po, sir.
Thank you. Wait lang. Let me go with my base PowerPoint. Okay. This will be a quick PowerPoint lang naman. This is consisting of 10 slides, 2 sample solutions from your book, from your lecture workbook, so that we can go over yung concepts kaagad. So again, good afternoon, class, and good to see you again after 2 weeks. I hope nakapag-enjoy kayo during engineering week. We're able to participate in activities. I do hope nag-participate kayo with yung professional services activities, like CV, yung thesis presentation, so that you get an idea what those are and how they look like. If not, you can ask your seniors about it naman, so that you have an idea rin. Hopefully, I heard na maganda yung news regarding COVID and yung policies natin regarding to face-to-face and online classes. As much as I like to maintain yung online classes, I believe face-to-face will be much more beneficial to you, and probably a face-to-face and hybrid setup, I think. I'm not sure nga lang pagdating sa logistic challenge dun kasi I think most of you are not in Metro Manila Center. So maybe that's a problem for another day. Either way, I'm glad na yung COVID situation in Pilipinas is doing good. And with that, let's proceed with the equilibrium model. Okay, of course you've read this over this now, so by now at least you have an idea what force and what type of forces involved in an equilibrium setup. In fact, some of you probably read in lecture 4. Lecture 3 and 4 are kind of related. It's just that the only difference here is that in lecture 3, you're primarily focused on systems that doesn't exactly move. Okay, it's static, and it doesn't really care about muna friction muna. On lecture 4, you actually incorporate that, because you're working with the systems that are not exactly static naman eh. Hence why important yung forces reacting on the surfaces rin eh. And okay, and of course a little bit of Newton's law review lang tayo. FBD, how they're made, what their purpose for, yung concepts of static, translational, and rotational equilibrium. Of course, board problems. The funny thing is, you've been constructing free body diagram ever since lesson 1. If you could recall yung vector analysis nyo about yung assigning yung vectors and knowing which direction they are, their magnitude, and what direction they're pointing at. That's kind of similar to it, except here we're talking about forces naman na, not just any vector. Okay, so quick definition lang. We all know the force is simply the push or pull of an object, or it's acted on an object on a surface. In an SI unit, it is 1 Newton, and we all know that 1 Newton is 1 kilogram meter per second squared. Quick Google lang rin, if you're curious lang, it's about also 0.2248 pound force. Yeah, that's the difference between rin ng English and metric. Normally, if you would indicate a mass, is kilogram. But if you indicate in English naman pound, especially in a physics problem, you have to indicate pound mass. May kasamang yung symbol ng pound and then yung M para designation niya as pound mass. If it's a weight, magiging pound force or pound F. Some of the forces that you're familiar with, they are contact forces and field forces, and as defined accordingly based on their name. Contact forces, you really have to touch it or apply physical contact. The field forces naman, they're inherent pagdating sa system, or they're just simply large enough to exert such amount of force, just like the force of gravity, and they act to empty space. We have your normal and tension force, Very important to. Kasi normal force is always perpendicular to the surface. And it's exerted by a surface to an object at contact. And normally when you have a weight or parang a block of weight involved, you have a gravitational force. Essentially, that's essentially weight na lang nga naman. And that's force exerted by Earth on an object directed towards its center. All right. Tension force, on the other hand, is yung pulling force exerted by the rope, string or chain, or cable on an object, and it's usually along the string, lies along the string direction naman. Wow. Okay, a snapshot. Law of inertia, force of acceleration, and action reaction. These are important things. I think yung first law and lalo na yung second law really applicable pagdating sa fourth lecture. But it's good to know that the law of inertia is the absence of an external, states that in the absence of an external force, a body at rest or a body of motion will remain at rest or in motion at constant velocity respectively. And so according naman sa law of force and acceleration, which is the sheer definition ng formula naman exactly, states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. Wait lang guys, wait. Resume share. Okay, good. Sorry. Yung third law is just simply yung action or reaction. When two bodies interact, they apply forces to one another that are equal in magnitude and opposite in direction. Just keep in mind those laws when trying to understand static and non-static equilibrium problems naman eh. Okay? Okay. Sorry, I was not able to read yung second question mo pala, Valerio. Are required to pass the solutions for solving parts of the exam. Don't worry, I will tell you what kind of exam it is on or before Tuesday or Wednesday once I finish designing yung quiz. Okay? More likely than not, probably I won't require you to submit yung solutions nyo kasi it's kind of tedious rin on my part. But for you to achieve yung answers naman, you might have to, use some scratch rin naman rin. And might have to require you to submit but not gonna be counted naman as part of the points. Then again, I'll just send you the final instructions on or before Wednesday na lang. Okay? Haven't really finished yung quiz, Valerio. Okay. So moving forward, some definitions pa. Okay, FBD, or your free body diagram. Like I said earlier, we've been doing this since lecture 1 and 2 na. It's a graphical representation where to show where the magnitude and direction lies. We do it minsan by parts, or we just do it as a whole, as a system, and we do it overlay on top of the shown figure. Okay, and then we have static equilibrium. It just states that a complete static equilibrium is achieved when an object is at rest and satisfies the following conditions, just as translational and rotational equilibrium. All right, there we go. It means that the summation of all x and y components, including your rotational or your moment forces niya, is equal to 0. Doesn't move, perfectly balanced. Okay. When I mentioned moment is simply a vector quantity lang naman. It's the force applied perpendicular with a perpendicular distance to its center of gravity or about an axis or pivot. So lever arm is just the distance in between yung pivot point na yon and the force being applied. It's just to get the moment, you simply multiply your force by the perpendicular distance towards it. If your force applied is directly at the center of gravity or in center of gravity, your moment will be zero because you have no lever, you have no distance to leverage it to multiply yung force. Okay. So let's do our first example. I actually asked some of your class kung may napansin kayong mali when it comes to providing yung given niya. Yung angle na ginamit niya on tension 1 here. But I will go over that later, no? So I took it straight from your surface for your surface tuloy, for your lecture workbook para at least you have an idea lang dito. Kasi the other problems naman are just a variation of the problems. The other variation here is naka-inclined plane yung block instead of nakahang. But we have a board problem for that, so I'll show that to you later. So in general, there's a lot of stuff nilagay sa lecture workbook, and if you read other physics books, there's a lot of breaking down. But essentially, it's condensed into several steps lang naman eh. You establish yung FBD nyo, so you basically physically draw it to just imagine where are the forces are ba and what angle are they in projected ba, so that you can lay out yung components yung X and Y components mo, and if ever man may mga rotational forces kaya dito or moment, so to speak. But if it's in perfect equilibrium naman, no rotational whatsoever, no beam, no hinge attached. So you're only dealing with translational forces lang naman dun. Okay? Then once you lay out yung components mo, you know what your X and Y's are. You now set up yung equation mo. You equate them to zero. Since it describes most problem under the static equilibrium or static nga naman, their summation of all forces will be equal to zero. So all you have to do is just line them all the X forces and then equate them to zero, all the Y forces, then equate them to zero. And then you now create your equations or series of equations so that you can solve for the unknown algebraically. Wait lang, hindi ko na-hide yun. Pakita ko na lahat. So I did that by, to show you example na lang. I mean, it's already in your book lang naman eh. But the only thing I did different here is I didn't agree with the book's designation ng angle niya dito. So I actually want to ask the class when we go to here, kung ano yung angle dapat ng tension 1 eh. So following yung steps natin, sige, let's go with point A lang muna. This is easy. Kasi understanding yung transversal planes wherein you have two parallel lines and then you have a line intersecting them, you would create some angles that are congruent to each other naman. Yun yung buong rule nun eh. Correct? So for example here, so we have build the FBD at point A and at point M. So you can build it separately or diretso mismo dito sa figure nito. Ako, I would prefer to just to draw it separately so that I can see yung system eh. So we have tensions 3, labeled here 3, 2, and 4 with their given angles naman eh. Tension 4 is kind of simple lang kasi it's perfectly horizontal. So it's going to the left. So that's T4 lang and there's no angle of inclination done. With tension 3 naman, it's being pulled at 45 degrees. Using yung traversal rule, so this 45 degrees here, pag in-extend natin to, it should be 45 degrees rin on an XY axis, right? So there we go, T3. And then here comes T2. Now, paano ko nalaman yan? Well, if you extend again yung Y-axis mo here, and yung buong to is yung obtuse to 130 degrees, you would create a 90 dito. And you're left with this particular angle. All you have to do is just subtract 130 with 190. You got 40. And hence, you got yung angle of inclination ni T2. So far, so good doon. Malinaw naman. Pagdating naman sa point M, since we're dealing with a hang mass dito, although it's not shown, we have already a weight pointing downwards towards the center of gravity. So we understood very well on the FPD na there's a mass times g pointing downward. There's a force being exerted on that given mass ng 20 kilograms. Hence, we are here. We have this one. And then, tension 2 is also the same tension dito. And the good thing about it, since meron na tayong angle dito, we know yung angle dito. This is 40 degrees, 40 degrees. If you gotta look up, yung opposite naman niya, which is here, this should be 40 degrees and per the transverse plane rule, no? Just let me know if I'm just butchering yung rule. That's the only name I know, eh. Okay? Tapos, here's a T1. Dito ako hindi nag-agree with him. So, tama ba sa workbook nyo nakalagay dito, 30 degrees?
Yes po.
Yes. So, any one of you agree with that? It's fine kung mali ako, which is, I'm okay with accepting that, eh. Pero, I really did took my book. Tingnan ko yung luma kong book about trigo and yung properties niya and yung algebra and try to see yung definition ng transversal planes, eh. It doesn't make sense na you equate that as 30 because it should be on the top, eh. Kumbaga, if it's east of north, that will be 30 degrees and then 60 pa rin sa baba, eh. Okay, no, Zui. What do you think is the angle, Miss Zui?
Same sa'yo, sir. 60.
Intuitively 60, right? Sige.
Yes, kasi kapag i-vertical line mo yung M is 30 tapos ano.
Yeah. Even kahit yeah, tama, no? Even if gawin mo siyang, wait lang, where's my pen dito? Even if gawin mo siyang ceiling, ganun pa rin, di ba? You still have to, you're gonna come up with 60 pa rin, di ba? Even if gawin mo siyang ganyan, meron pa excess dito at 90 degrees o 120, pero you still have to come up pa rin with 60, eh. Kasi you have to cut it up pa rin naman, eh. Correct?
Yes po, sir.
All right. I'm glad the class is on board with that. Pero yeah, no hate naman pagdating do sa book. Probably na kamali lang yung type. Either way, the whole point naman doon is that you can still follow pa rin yung book, not just the steps lang naman, eh. Okay? Sige. The steps is pretty much the same pa rin naman whether 60 or 30 siya. Pero in this case, I think dapat talaga 60 siya. So I'm using yung 60 dito. So you might see a different answer lang naman from the book kasi the book use yung 30 degrees dito. Okay. Wait, they have my pointer pa rin ba? Okay, good. So after ma-establish ko nga yung FBD, it's kind of, pag tinignan mo to, it's kind of easier to lay out na may equations mo, yung X and Y component, eh. So I did first yung M kasi I know very well, I already have a weight, eh. Alam ko na to, given na ta sa akin to, eh. So in short, I'll be given like 2 equations dito and malalaman ko agad yung T1 and T2. Okay, so I did yung summation of forces X0 and Y0. So inalign ko lang lahat ng X forces ko. So looking at this lang, so we have positive TX. Dapat sinulat ko pala yung TY, TX para mas malinaw, eh. So we have yung T1 cosine 60. It's going to the right naman, so that's positive. We have T2, yung X component going to the left, so that's minus T2. I'm just using yung angle dito. So on this perspective, that's T2 cosine 40. I'm sorry, T2 sine 40 pala. You could also use yung kabilang angle niya and just use simply as yung T2 cosine 50 degrees pa yan. Pero it will arrive at the same answer pa rin naman, eh. And then yung summation of, so that's it. So wala naman X forces yung yung gravitational force mo dito. Pag Y component naman, we have yung positive T1 sine 60. You add up yung T2 cosine 40 since we're talking of this. Wait lang. Let me have yung, cannot have yung pen at the same time, eh. Since we have this. Yeah. So follow lang yung basic rules pa rin naman, it would still arrive with the same answer para. And then, but you have a negative way because it's pointing downward, so it's opposite, eh. Okay, So you have this. The good thing about this is that you know FG already. You just multiply 20 by, for this particular examples lang, I just use 9.81 na lang muna. I will tell you what kind of 9.81 you would use if you would need 9.8066, 9.8 lang, or 9.81. So don't you worry about it. Okay? And then you set that up, and you will have this second equation naman na. Now, all you have to do now is yung next step natin, solve this equation simultaneously. So if you look at it, you can either isolate one component over the other and just substitute na lang. In my case, I did that. I think I made all the equations in terms of T2. You can do it all in T1 if you want. And then solve for, and you would eventually get the answer of T2 and T1, 107.79 and 138.57. Okay? Sige, yeah. Then of course, from here, you now have a given na from the other side. We have yung T2. So you can, kasi pag nilatag mo agad yung point A, you would notice na meron kang unknowns na tatlo. And you really eventually pupunta ka din sa point M just to solve yung T2. So kaya inuna natin yung T2 just looking from the diagram, okay? So from there, again, you repeat the same steps. You now have your FBD, you set up your X and Y components for point A naman, just like so. So that's T2. That's T2 going up. Sorry. Ito yung X component niya, T2 sine 40. Okay, that's why it's positive. And then we have yung T3 going here. So that's sine 45. And T4 just completely horizontal on the opposite direction, minus T4. Ang maganda naman sa Y component niya, there's no T4. Okay, and we simply have minus T2 cosine 40 and positive plus T3 cosine 45 degrees. We set them up, substitute one or the other, and then you're able to solve them for T3 and T4 respectively. And this is what I got. Okay. These steps in the book is really similar lang naman rin. It's just that sa haba lang ng equations niya. Okay, and this is just how I solve it lang on my own. And using 60 degrees. Questions? Okay, no questions. Sige. Easy peasy. I'm pretty sure nakita nasa lecture workbook nyo naman, and there's another variation naman there for the inclined plane. The process is still similar pa rin naman eh. And in most cases, pag static equilibrium naman, you won't care about your friction exerted by the inclined surface. Not at least hindi mo na at this particular lecture. Okay. Sige, moving forward. Per the calendar, actually, we're kind of early. And naka-indicate dun sa course outline, we're supposed to have a 2 session ng lecture 3. One is for Newton's first and third law. The other one is for rotational equilibrium. So we're gonna go definitions na ng konti dito before we go dive right in sa problem. But since last week, probably you've read most of it na. So daanan lang natin mga definitions and let's go right with the problem kagad. Okay? So, yung rotational equilibrium is one of the conditions for static equilibrium. So translation and rotational equilibrium are both considered, especially when an object is dealing or are dealing with non-concurrent forces naman, which in turn cannot be modeled as a single particle. Okay. Before kasi the forces can be aligned, concurrently, but here we're dealing with non-concurrent forces. Yung nomenclature natin pagdating sa direction of moment, counterclockwise is positive, clockwise is negative. Okay, I think that's the nomenclature ever since. And as mentioned earlier, yung summation of moment niya should be equal to 0. And depending on what kind of hinge or support you are, sometimes you have vertical and horizontal components to look for. And as stated before, the moment is simply just the product of the force applied and its perpendicular distance to its pivot point, or yung, yeah, or rotation of axis. So this one is just referring to this figure here. You can see that the forces 1 and forces 2 have moments, and unfortunately for force 3, it doesn't have a moment because it doesn't have a distance to lever it with. It has, however, depending on which direction you're looking at, it could be a horizontal or simply a vertical force being applied to it. Now, unless we have moment at 0, wala na kagad yung forces na yun kasi it's not considered that you're only dealing with F1 and F2. Next. Yeah. So depending on which reaction forces you are involving, you would have at least horizontal and vertical reaction. These forces are exerted by yung support ng roller, pin, hinge, or fixed beams on an object. These are properly defined in a problem naman, but in its practical sense, these are actually very practical when you're doing with heavy machineries, especially with really heavy loads. The good thing naman is when operating yung mga heavy equipment na to, there are standards, yung maximum load nila and minimum load nila. Even with the maximum load, there are safety standards where you don't have to reach, or you don't have, you should not make the equipment carry that much but it's a maximum niya kasi it can only hold for X amount of time. So it's better to, hold it at a certain weight below yung maximum niya. So in this case, roller, pin, hinge, and fixed support. So pag roller, yung problem, it's simple, it's moving and sliding. So yung horizontal motion siya is completely negligible for most of the time, unless specified otherwise. They have only vertical reaction only. If naka-pin siya or hinge, talaga parang naka-rivet siya doon. You both have yung vertical and horizontal reaction accordingly. If it's a fork, it's a fixed support naman, you both have all vertical, horizontal, and yung moment reaction. Mostly meron ka sa mga cantilever beam, and if you're gonna compete further down the line pagdating sa other physics subject nyo on mechanics, you'll be dealing mostly in cantilever beam and yung stresses ng strength of material nun. And primarily, you care much about yung vertical, horizontal moment na to if you're dealing with designs that have a lot of suspended supports, and they just really rely on yung strength ng material itself just to make sure that it doesn't bend or buckle. Okay. So again, I just took it straight from your problem naman sa surface workbook nyo. Just to give an example lang naman. And we have board problems naman to show yung other variations of the problem naman. So we have here a simple seesaw problem. So we have two guys here, Tony and Steve, that weighs 35, that has a mass of 30 and 35 kilograms respectively. They're sitting on a seesaw with that's 4 meters in length, and the weight of the board, this is a seesaw, is 1 kilogram. The support is under the center of gravity of the board, so it assumes nasa gitna siya. Okay, so and Tony is placed like 2 meters away from the support, so halfway done. We're being asked to determine how far must Steve sit from the center of gravity so that it's perfectly balanced. And letter B, what is the magnitude and the magnitude of the upward force exerted by the support here? Okay. So even though the moment siya, the steps is pretty much similar, is still similar. You first build your FBD, you set your moment equations to 0, and then you solve simultaneously to find the unknowns. Okay, so we did that by drawing it separately naman. I usually do, this is best practice na isolve na i-draw mo siya separately so that you can see yung forces mo dito involved muna before laying down the distances muna. So what are the forces that you're dealing with muna? For one, the board weighs about has a mass of 1 kilogram. So he has a force of gravity doon. Let's call it FGB. You have yung weight ng tao, Tony and Steve, so 30 times yung G, 35 times yung G. So we have this pointing downwards. And then of course, you have yung support dito that is, I think it's since it's only vertical, so I guess it's a roller thing. It's a simple one. It has a vertical reaction. Let's call it RO. Okay, reactional support. And once we've determined na yung forces natin, we just lay down yung distances. We know that Tony is 2 meters away from the center. The drawing is not to scale, but bear with it. And then we're asked to find this guy. How far must Steve sit from the center so that it's perfectly balanced and hindi sila gagalaw? I mean, you played this as a kid before, and intuitively, you kind of know because you kind of feel where the force doesn't actually make you rotate or move, diba? So that's what we're trying to achieve. Okay. The good news is that you have yung mga masses na to. So you can automatically compute na for weight ni Tony, Steve, and ng board. So you just plug and play them later. Okay. So your next step nito is, of course, setting up yung equations. You will also notice na I won't be using all of them. Okay, so what really matters is you create equations done enough for you to solve yung mga given variables naman dun. But in this case, I just laid out all the moments at particular points naman. Okay? So let's go with point O or point origin. Let's just say yun yung gitna dito. So at yung moment at that equals to 0. So we're talking about pag nandito yung reference point natin, wala na yung RO and FGB natin. So we're just talking weight ni Steve and Tony lang dito. So Steve here is in what direction? Steve here, pag dito tayo, Steve is moving in a clockwise direction, and per our nomenclature, clockwise is negative. So when we have negative moment is Steve. On the other side naman, si Tony moves counterclockwise. So that's positive moment siya. And you just lay them down yung definitions ng moment nila. That will be force ni Steve times the distance times the distance towards its center, which is 2 meters. And you multiply yung distance ni Steve by yung hinahanap nating LS. Okay? So that's one. So you move naman to point A. Pag point A naman, you cancel out yung forces ni Steve. So now you're dealing with 1, 2, 3 forces. Namely, reaction forces, weight of the board, and yung weight ni Steve. So from here, let's start with RO lang muna. So pag dito yung moment niya, paano yung galaw? Wait nga lang. Paano yung galaw? So pag ganun siya. So it's counterclockwise. So positive yung moment ng reaction. Pag ang galaw naman ng weight ng board is here. So it'll be clockwise siya, no? That will be what? Negative. The same way when kay Steve dito. So negative yung moment niya. Hence, we have yung equations na to. In fact, that's already enough to solve the equation. But I just want to point out that you can also use yung B, and you would yield naman the other way around, since magiging clockwise naman si Rho, since yung reaction niya, di ba? Pag ganito naman siya pag moment B. And then you'll be dealing with your forces ni Tony pag ganito, and yung weight ng board pag ganito. Hence, you're given this equation. Now, if you have enough equations na dito, now you solve them simultaneously naman. So, ano yung equation na pwede mo masolve kagad? In fact, actually, yung moment 0 mo dito, you can actually solve for the length needed ni Steve to sit down. You simply substitute yung mga forces ng weight mo and yung board, and you will have this one. Then after that, you substitute that. Yung pala given lahat, ano? You substitute it to either of the equations na meron ka dito at point B or point A, and you'll have with rho na 646.72. So far, so good. I mean, Malinaw naman yung process. O time check lang. 2:38. That's now. Okay. Gonna stop sharing dito and focus more on the problem set na tayo. Okay, switch to OneNote. Share screen and wait lang. Let me just end lang yung screen na to. And show, discard. Share natin yung OneNote. There we go. I believe I solved this. Yeah, I pre-solved this na so that parang mabilis tayo. I'll send this naman sa inyo later. Are you able to see my screen na here? So far, okay. Okay pa naman siya. I was able to solve yung problem ko when it comes to phantom touch ng mga tablet, especially yung sakit ng lumang surface. I just disable na lang yung actual physical touch. So all I have to do is just input na lang yung pen and yung mouse eh. Yun nga lang, I have to operate it simultaneously. Eh. Okay, so this is yung board problem provided for equilibrium model naman. So we have yung another variation of problem ng static equilibrium, which is naka-inclined plane siya. Okay, let me just, yeah, baka magulo eh. Yeah, let me just, there we go. Wait lang. Let me just erase yung board. There we go. Hi. There we go. You're gonna mabubuo pa rin. Just using green so that we can, follow through. Okay, let's read the problem. You can solve this simultaneously sa akin, pero if na-solve nyo na, that's great. Hopefully we got the same answers naman. Do let me know if we got the opposite and point out where I'm wrong, if ever, okay? So, burahin lang natin to. There we go. Okay, so we have an inclined plane, a block resting in a plane inclined at an angle of 32 degrees. So automatically, you know from the figure below that the theta they're referring to here is 32 degrees. And it's being held by steel cables at A, B, C. So we have yung tensions dito, A, B, C. And the tension in cable B is already provided at 80 newtons. So that's particularly this guy. Okay. And then and also note that the cable A is parallel to the surface of the inclined plane. So it's very important to note that this guy is parallel here. And it's also important na you can actually do yung angle niya rin dito. This one should be equal yung theta provided rin. Okay? And cable B is perfectly horizontal. We're asked to build yung FBD at point D and identify yung tensions ng tension ng A, which was this one, and C. And B naman, to create yung FBD around the point block M. This point is as point M na lang. Ayan. And determine yung normal force. Yung normal force. And yung force of gravity. And eventually yung mass niya in kilograms. How are we to approach this? So we'll deal the way na nilatag ng board problem, in-intentional niya na to ask to solve for D muna and then go to M. Because normally that's how you would do naman eh. So you solve them one by one. So we start with this muna. Okay? Before going to M. So building yung FBD based sa figure. Buray natin muna to. Medyo cumbersome na eh. Okay, there we go. So we're dealing with this guy. You can simply draw it on top or just again simply copy it and then try to imagine yung forces nyo. So here similar dun sa problem na kinuha natin kanina, pag in-extend natin yung x-axis mo and using yung transversal rules mo, 42 degrees here is equal dito sa angle rin ito, which is this one, 42 degrees. Okay? And then, given na yung tension B mo, which is 80 newtons, so nakalatag dyan, along the positive x-axis is 80 newtons, and you have A here at an angle rin. But you would imagine na since parallel siya sa ground, it's inclined at a particular angle. And if you extend yung x-axis mo doon and yung y-axis, you would notice na itong angle na to nga is equal dito. Hence, you get 32 degrees. So far, walang question doon. Wait lang, ilabas ko lang pala yung chat nyo para hindi ko makita minsan pag naka full screen eh. Okay. Do type in if you have any questions na agad. And of course, after mo ma-establish yung FBD, now I set up na equations ko equals to 0, yung x and y components ko. So I did this. For x components, we get yung TV. Perfectly positive, going to the right. And then let's see yung TA and TC, they're all going to the left. So yung X component nila would be negative. So you have yung minus TA cosine 32 and minus TC cosine 42. You set that up yung equation, simplify it. So since may 80 newtons ka, so ito yung magiging first equation mo. After that, you set up naman yung Y. So you have yung Y component. Walang Y component yung TV, that's completely zero. So you're only involving TC and TA. So the Y component ng TC is TC sine 42. It's pointing upward. So pag yung TA naman is going downward, so minus TA sine 32. That'll be equation 2. And what you do is just solve them simultaneously. Like I said earlier, you isolate them. You solve for one variable muna and then substitute with the other equation. So what I did is isolate it. Yung equation 2, I isolate to TC. And then whatever yung value nun, I substitute it to equation 1. I simplify and got these values. Our answers might be different by a decimal or so, depending yung number of significant figures natin, but that's fine. Okay. So going now towards problem B, again, we're asked to solve what is yung FBD ng point, build yung FBD at the block and determine yung perpendicular force and yung force of gravity. So ito siya. The book, your lecture workbook showed it differently. In fact, when I first solved this, I just solved this using this sample lang eh. Tong ganitong FBD. In fact, that's for me, that's already good na for me eh. But I noticed na, nga naman, mas madali nga naman if you would shift it and reduce yung number of component X and Y components mo computationally. Because if you do this, you still have yung angle for normal force and yung angle for tension A eh. But as for definition of normal force, it's always perpendicular. It's best na eliminate na lang yung angle. It's just shift lang yung axis eh. And you just have to account na lang yung shift and axis. So from yung Y and X axis mo dito, magiging Y prime and X. So it's just shifting. It's simply shifted by 32 degrees lang naman rin eh. Since ito yung angle rin naman at which it's being applied for eh. Okay? Yan yung buong angle rin naman dun. It's the same eh. So when you shift it, the buong axis nun, the shift it's entirely by 32 degrees. Hence why we got that. Now, yung angle mo na lang is yung yung FG na lang may pakialam ka dun. Okay, and then of course you set it up similarly. The next steps naman yung x and y component summation equals to 0. So when you do that, you already have yung TA mo dun. You have yung TA minus FG sine 32. If you could see, it's a lot simpler lang naman compared to kung ito yung gagamitin mo. Okay? And then you push the equations on the other side and you will get FG of 105 newtons. You substitute that with the y summation of y naman, you will get your perpendicular force at 89.05 newtons. And then simply since you already know yung formula ng, since we're dealing with gravitational constant dito, we have yung force times ma, but since we're dealing with gravity, we got force mg. Yung force of gravity lang naman dyan eh. Simply isolate and then simplify and you'll get the answer ng mass at 10.7 kilograms. So far, so good. Okay. Sige. It's pretty similar pa siya, okay? Okay. All right. Okay. Wow, medyo sakit. Okay, dun sa board problem number 2 naman, what I like about it naman is a combination of moment, rotational equilibrium and translational equilibrium forces dito. So we have here a parang train, so to speak. Eh. Yeah. Wait lang. Get an idea dito. Na-solve nyo na ba yung board problem number 2? Can you show it by show of hands lang? Anyone? Na-solve nyo na ba yung board problem number 2? Guys, I'm big on participation, by the way. In fact, I am setting up yung grade systems or your pointing system so that you won't really fail on the class, so that you rack up any points no matter what the participation rate is. Okay? Ever tried solving a board problem on your own? Hindi pa po. Okay, good. Okay, good. Sige. I'm really having problems right now and it will require me just 5 minutes. If I'm gonna be honest with you, I just want to deal with this lang muna. I want you to solve it muna and then I'll show to you yung solution. That's okay. Okay ba yan? And maybe I'll call on a volunteer just to help me out lang. Okay ba yan? Sige. So, I'm just gonna leave you for 5 minutes and I'll be back. Okay? Wait lang. Wait lang. I have an idea dito. Copy, paste. Ay, mali. Para naman duplicate slide and mag-insert ako ng insert. Sige. I'll be back in 5 minutes now. Hello, mic check. You guys are still here? Okay. Sige, I'm gonna stop dito and switch back sa and show. Hindi pala siya naka-loop. Okay. Okay, I'm gonna switch back sa OneNote ko. Share screen, OneNote. So, kind of be able to solve it in 5 minutes. Sige. Play na lang natin. So again, yung first step dito is to actually build yung FBD muna. So there'll be no wire forces dito. And I understand na I said before na you can actually draw it on top of the figure or just draw it separately. But in this case, since maganda naman yung figure and it's perfectly clean rin naman, I thought na, sige lagyan natin, kulayan natin. Okay? Wait lang. Tanggalin ko muna to. And ito para at least. Yeah. Okay, there we go. So we're asked to find muna is yung tension ng cable at T here. Okay. The reason why I put it here is doesn't really matter kung dito rin naman kasi it's definitely, if it's in static equilibrium, that tension should be equal rin naman. So let's put it here since dito at least meron tayong angle dito. And then we're here to find rin yung reactional forces ng beam or hinge, which is to. Since naka-hinge, if you would recall, meron kang y component and x component accordingly. Okay, and what else yung given natin? We were given a beam with a weight of 45 kilograms na naka-hinge at 45 degrees. So we have yung weight ng beam. We also have a mass hanging on it at the end of it. So we have 225 dito. So you automatically have weight na rin. So you have 1, 2, 3, 4, 5 forces na involved. Okay, now that you know that, i-layout mo naman yung mga angles mo dito. Originally, hindi given. Ang given lang sa'yo is yung 30 degrees and yung 45 degrees. And eventually, you have to find rin yung angle neto. It's kind of easy naman. Using just this 45-degree angle, you know that this is 135. You know that, wait lang, saan ba tayo? You know that this would be 135. And you add that to 30 minus 180, you would get 15 degrees dito. And this one, you would eventually get to 30 degrees. Kasi, just to check it lang, yung angle neto should be identical to this particular angle rin naman, which is 45 naman. Yung total angle nito, this should be 45 degrees rin. Okay? So now na na-establish natin yon, wait lang, kaya natin yan, siya na madumi. We now set up equations natin to 0. So in this case, we have x and y forces and yung moment and moment forces. Okay? So just like what we did earlier, so you set up muna yung x forces equals to 0. So we're dealing with all x's muna. Yeah. So we have yung reaction component. So technically, if I'm gonna represent it properly, meron siya yung resultant niya dito, ganyan. So ito na yung kaakibat na R and Y forces niya. So we have this as Rx cosine 45 degrees. That's going. Wow. That's going to the right, so that's positive. You have, what else pa ba? You have T going on the opposite direction, and this time it's minus T. You're dealing with this. Wait nga lang. Ayusin natin para makita nyo. So essentially, we're dealing with this particular tension dito eh. So you have yung Tx niya dito and yung Ty niya, which is technically going downward and this one going to the left. Okay, so you have yung Tx mo as minus T cosine 30. Okay, then equals to 0, and that will be your equation 1. Next is yung if wala nang iba, you go with the y forces mo naman, y components mo. For y, you have yung weight, ng beam, you have yung weight ng block, and then you have yung y reaction forces ng hinge. So you start with that. So yung ry mo is pointing upwards, diretso lang naman siya. Okay, so ry along the y-axis, and then what else? We have yung ty mo pointing downward at, like I mentioned it before, this is 30 degrees. So that's minus T sine 30. What else do you have? The weight of the beam going downward directly, and the weight of the block. So minus F beam and yung F block. Yeah, that'll be your equation 2. You can now, the good news is here you have already your masses na ito. So you can automatically solve yung weight ng beam and yung weight ng block, which you would get around 441.45 newtons and 2207.25 newtons. But we're not done yet. Kasi we have rotational forces, so we have to accommodate for that. So let's just assume that yung distance nito, distance ng beam ay L. And you soon later find out that wala pala tayong given distance ng L. But if nilatag mo na yung, do not panic pag ganun. You just have to think calmly lang. Lay out mo na yung equation muna. Baka naman there's another way around. Okay? So, sige. You have yung forces mo. You have yung length mo naman as L. So let's put it that way. It's summation of moment at the hinge. So dito tayo. Automatically eliminated na agad yung Ry and Rx mo dyan. So you're dealing with the weight of the beam, the weight of the beam, yung tension forces nun, and yung weight ng block. So if you're gonna lay it down yung moment nun, weight ng beam is going to be clockwise, weight of the block is going to be clockwise. The weight of yung tension forces naman would be counterclockwise, hence negative, positive siya accordingly. And ito lang naman yung distance niya, and with its particular inclined angle rin. And you will see this na you can actually factor out L. You can factor out L. And maka-cancel out sila to 0 naman eh. And you would left this particular equation na naman. And from here, you can now actually simplify and solve for T. So going to solve for T, you're just simply simplifying it. You would arrive with 6,633.35 newtons. Now that you have this one, you can just simply substitute it to the respective equations and you would arrive with an Rx, Ry value of this one. Using yung equations na to, just substitute yung T dyan and then dito. You will get 5744.65 and 5965.375 newtons. Actually, just 38 na lang is fine. Para pare-pareho. Okay. Questions? Before I move dun sa board problems natin, which is 3 o'clock naman na. We're at the second hour naman. All right. Anyway, hindi naman to yung primary focus. We can go over with more problems naman with this in the future since we're kind of early actually. Per the schedule, we're actually supposed to have our quiz this week. But that won't be fair naman, especially if we haven't met pa. So I thought na, you know what, let's just go over with some of the problems lang and then let's have the quiz the following week later naman. So we can adjust accordingly as we move towards Holy Week. And don't you worry, yung quiz number 2 nyo naman is just after Holy Week naman, unless there's a memo provided na do not declare quiz after Holy Week. Okay? Sige, I'll send this over naman sa inyo in print format. And I hope my writing is as legible as ever. I admit I don't have the best handwriting, but it's the best I can do. Okay. Let's go with problem number 2. Yeah, I wasn't able to finish solving them. I tried to solve them live, actually. It really consumed most of the time. It's just writing them, the equations done. So for here, I'm gonna solve yung board problem number 1 on lecture 1 and yung PPE number 2. I was already able to solve yung problems 1 to 3, and then hindi ko natapos live yung 4, 5, and 6 eh. So maybe you can help me with that later. Okay? If ever man di natin matapos, I'll just send you complete equations done. All right? Right, sino nakasagot pala ng ano? I think most of you were able to answer yung board problems naman, and I think most of you arrive at the same answers dito. Ano yung sagot niyo, just so that I know what we're talking about dito. Just shout lang yung final answer niyo. What is the x component ng EX doon, if you could recall? And we'll later find out if parehas tayo. Any volunteer? Just type lang yung answer nyo. What was your answer pala before? X 7.81. And F? Say, continue, Ryan. Yeah. At what particular direction? Yeah. All right, let's see if yun yung nakuha ko ring sagot. So, I imagine you set it up by, it's actually an easy problem rin naman. All you have to do is just set it up yung components niya and try reading how fast you can actually solve this per component niya. Okay? So, you first set up yung given muna. So, we have yung sum of vectors DEF, which is yung resultant, and already have a magnitude and direction of 24.8 and 21.34 degrees west of north. So you have this already. It also stated na yan yung equation niya rin yan. Summation of all forces. And you also know that this is applicable as well. And then you're given with the vector D, 30 degrees southwest. And we know very well pag sinabi natin southwest, that's automatically 45 degrees. So, yes. Okay, pala. So, it's kind of like that na kaagad yun, no? 45 degrees. Okay? Sige, balik natin. And then you have yung y component ng E, which is at negative 44.32, and yung x component at 20 centimeters. Important to note that yung binigay nila yung sign. So what does it tell you? That the y component ng EY either lies third quadrant or fourth quadrant. It's probably in between them, depending on which the x quadrant is. It's possible lang naman na yung x component niya is either on the third or fourth quadrant. Okay, and if fx naman tells you that you have a positive fx, so most likely as a first quadrant siya. You're just here to determine na lang where y component lies rin naman. Okay? Hey, what the hell? Okay. And then we go for, so try solving it. The first thing I did here was setting up, okay, ano yung mga R components ko, like yung RY and RX go. So I did that by getting yung, where does my R lies ba? So it lies on the third quadrant. I realized based on the direction na meron tayo at 21.34 degrees and so I got the opposite of which is 68.66. And yung R natin here is 24.8. We already have yung RY and RX values natin here. So I just put it there. And alam ko rin kung ano yung X and Y components ng D. So we have yung this one and this one. And I believe hindi ko lang nalagay yung negative signs dito. It's supposed to be negative, inherently negative. Yan. There we go. And then from there, we're asked to solve yung EX. If you recall, yung summation ng resultant forces is equals to the sum of all the vectors that are involved with it. Same rin siya with the X and Y forces. Yeah. So recall na Rx equals to dx plus ex plus fx. You simplify equation to have this para na-equate siya for ex. And since we already have yung values na to, Rx, dx, and fx, we simply just substitute yung value with its appropriate signs and you would achieve 7.182 nga. 7.812 pala. So far, so good. Yeah, I think parehas tayo nasagot doon. And then you next here, yung magnitude and direction ng F. The good news is you have already yung Fx. You need na lang yung Fy, correct? And another good news is you already have Fry, you have dy, and quite frankly, you have EY. So all it's left na is to solve for yung Fy na yun, equate yung equation na yun, and you would get 88.633 centimeters. And it's just a matter of substituting na lang and getting yung angle. And you would get 90.862 and 77.28 degrees north of east. Paras ba tayo? Yeah. Parehong-pareho. 86 sa'yo. It's a big difference, ano? Did I use it wrong ba? 88.633 divided by what's yung 20, di ba? 20. Shift tangent inverse answer 77.28 pa rin sa akin eh. Pero siguro it's just a matter of yung degrees lang naman. Okay. No problems, Ryan. No problem. Sige. Everyone got this naman? So to those who got this, I already recorded yung PP number 1. I'm happy to say na, hey, no worries naman, Ryan. Okay lang yan. Just not on the exam, no? Okay. Before, if your process was right, but you still got the wrong answer, my former professor back then under this was Professor Delenya, and she would still correct yung effort mo, but there's a significant shave off some points kasi tama naman yung solution mo, but you still didn't get the right answer. So parang thank you, I guess, kasi may points pa rin, despite my wrong answer, for appreciating my effort. Pero on the quiz naman pala, I'm planning to design something along the lines of multiple choice and fill in the blanks. Yung solving part, I'll try to design where you can actually try to solve it in your head, pero you can still use yung calculator nyo. Okay, so that you can actually solve your problem. And hopefully I can design a quiz that could, that you can solve within an hour lang naman. Okay, I understand this course outline, you're given 2 hours, so I'll give you that. Pero I'll try to make it, that you can solve it in an hour already, so that you can actually review and relax on it. Okay? I'll tell more in details on or before Wednesday, because I haven't really finished yung test. Not exactly how, but I don't have yung access to Blackboard feature, so I'll try to you know, make it different per section rin naman rin eh. Sayang naman eh. Yeah, that's a valid question, Emily. Uh, fill in the blanks. It does have choices. Don't worry. Just stand. It has choices. It's just that parang you just have to find it lang muna. And syempre, you have to confirm lang if tama yung pipili mong choice doon. Don't worry, you have choices doon. Okay? As to saan tayo quiz, I would imagine na mag-zoom tayo just like this and it'll provide you a link either in a forms or in a different format lang naman. Okay? But I'll finalize muna yan, Emily. Okay ba yan? Emily? May yata ng... Okay, sige. There we go. Okay. Madali yung unang problem, board problem. Let's go with yung PP number 2. Okay. I actually tried to solve this live kanina pero I pre-solve it na kasi I think it's pretty easy naman. And this is similar to yung variations ng problem nyo on surveys book and sa lecture workbook rin. It involves a little bit of first derivative and second derivative lang naman. So let me run through you with the process pag nakita ka ng ganitong problem eh. You read first the problem definitely and make sure you got the parameters right. Kanina lang is parang namalikmata ako. Talagay ko like 3 to T2. So, but that's on me na. So you write them up. You have a given with the equation ng quotient ng 4t cubed plus t squared over t and plus 3t squared over t cubed plus 4. There's a lot of t's. In fact, you can actually simplify it further. Okay, we're being asked with several conditions here. Yung una yung average velocity at particular time t, 1 second and 3 seconds. Instantaneous velocity at particular time t, and the average acceleration of a particle from t at t 2 seconds and 3 seconds, and of course, instantaneous acceleration. So it's just an exercise of understanding the difference between average and instantaneous velocity. And if you know and you recall yung concepts, average velocity is just really pinpointing yung start and end, and not exactly yung nuances on the vertical, on the velocity time curve. It's mostly you're just dealing it with a straight line, but you're not dealing in per point on the curve. Okay, hence why you have yung calculus nyo. And instantaneous velocity naman is yung finding yung that velocity at that particular moment in time lang. Okay? And if you're being asked ano yung instantaneous speed ng equation, it's just yung magnitude ng instantaneous velocity without yung direction lang naman yun eh. Okay? So to solve it, like I said, I believe you did it in this manner rin naman. I haven't really checked yung PP number 2, but it's a good thing most of you submitted na, di ba? I saw yung emails. Did you guys submit na ba? Wait, baka naman Oh yeah, there we go. Kinabahan tuloy ako, pinapakita ko na yung solution. Pero that's fine. Okay lang naman sa akin. So, if anyone intuitively, you would simplify kasi ang daming T. So you eventually have to cancel this out lang naman rin. Cancel. Ito pa. So you would end up with this. 4t squared plus t plus 3t raised to negative 1. It's going to be represented as t, but don't do that na lang dito. And then we all know very well that velocity is simply, we normally know that velocity is delta x over delta t. We all know that the first derivative, the change of x with respect to t, the first derivative of a displacement is just simply velocity. The second derivative of this displacement is already yung instantaneous acceleration niya. So you set up the equations mo na ganyan, 1, 2, and 3. Since you're dealing with instantaneous and average conditions respectively. So for A, to get yung average velocity, recall that we have V average as delta x delta t, which is final displacement minus initial displacement over change in time. In this case, we're given a time 1 second and 3 seconds, but we don't have x. However, we're given the equation. So all you have to do here is to get yung final mo and yung initial displacement is to substitute this guys sa equation 1 mo. And I believe you would get 44 and 12 meters respectively. And from there, you substitute and you will get 16 meters per second. And if you would see, there will be a pattern lang naman dito. It's just merely substituting it with the given equation lang naman. So pag nakakita kayo ng ganitong equation, for one, don't underestimate it. Pero at least when you read about it, I think at least you know you will get some brownie points kaagad. Okay? So from here, we are to get yung instantaneous velocity. And since we already have yung first derivative niya, all we have to do is just substitute lang yung t here with 2.5 seconds, solve for it, and we will get velocity of 20.52 meters per second. What's the final answer? Okay, so far tama pa tayo. And then we get average acceleration naman at t 2 seconds and 3 seconds. So for C, we substitute it simply sa we haven't given time, pero do recall na yung average acceleration is simply delta v over delta t rin na naman eh. So which is this. So you have yung final and minus initial velocity over time final or minus initial time rin eh. However, you don't have yung velocity I. So the good thing is we have yung first derivative naman done, and just simply substituting yung prescribed yung mentioned time moments nila at 2 or 3 seconds, you would receive yung 16 point Control Z yung wait lang device manager, where are you? Weird. Okay. There we go. There we go. Zoom out, zoom out. So you would get 16.25 meters per second and 24.67. Just substituting it here. And yung time mo, you would get 8.42 meters per second squared. So far, so good, I think. I think nakuha ko yung answer dito, 8.42. And then, we're being asked naman at D, yung instantaneous, what is the time t at which the instantaneous acceleration of a particle is 8.10 meters per second squared. So the difference here, we're given yung instantaneous acceleration. We just want to know what was the time at that acceleration moment. So it's a good thing that we already set up equation natin yung second derivative nito. So all we have to do is just isolate everything, t, and then solve for t. And you would eventually get 3.91 seconds. Kuha naman yun. Yeah. So, for those wondering naman, I can provide naman to kaagad. So I'll just have to print it lang naman. Okay. Sige, let's try solving for 2. Actually, I pre-solve it naman na. Hopefully, ma-solve ko pa yung remaining. This one is a classic example of yung different conditions at which yung speed train is operating. So you have yung constant acceleration phase, yung constant speed, and then going back to constant acceleration if you would notice. So yung subway train starts from rest and accelerates to 2.5 meters per second squared for a duration of 15.9. So that will be your first condition. Indicating that it starts from rest, you already have time 0 and initial time and initial velocity of 0. You have yung 15.9 seconds yung total duration. So hence yung delta t mo dito is 15.9. And you have a constant acceleration of 2.5 meters squared. And we don't know pa yung final velocity here, but we have a clue pagdating sa second state. It says there, after 15.9 seconds, it then runs at a constant speed for 35 seconds. So from there, you know very well yung initial velocity niya was yung final velocity ng first state. And yung final time mo from the first state is yung initial time mo for the second state at 15.9 seconds. And it says here for another 35 seconds. So you know yung final time mo before decelerating at the rate of 4.5 meters per second squared. So you have your final time for yung second state at 15.9 plus 35 at 50.9 seconds. Okay? And you know that your velocity here is constant. For the third state, you know that it decelerates for 4.5 meters per second squared. Several things. You know that yung final velocity mo will be 0 kasi you're going to a stop at the next station. You know that yung initial velocity mo is yung previous velocity mo, which is constant. So we're still looking for that. We're being asked the following. What is the speed on train just before it slows down, which is this one? And how long did it take for the train to finish the trip? So the entire trip here. So we have yung time dito, but wala pa yung time dito. So we just have to add them up lang naman. Okay? We solve this. If you would recall at constant acceleration, this equation, Vf equals to Vi. Wait lang, pangit ng delta t ko dito. A delta t. And if you would recall, this particular delta t is just simply 15.9 minus 0. You equate you substitute yung mga given values nyo with initial velocity mo 0, and 2.5 is yung acceleration given at that time, and it's positive since you're accelerating. And then 15.9 seconds, you would achieve 39.75 meters per second as your final velocity mo. Okay, and then from there, that's actually a good input na kasi yung input ng initial velocity on second state is constant. So here will be your initial velocity towards second state na dito. Now we're being asked for equation na okay in time. So in delta t at the time naman is just simply 35 seconds lang naman yun. We already got that kasi 35 seconds yung buong duration niya. At the third state, we go back again at constant acceleration. So yung final velocity mo definitely is 0. You already have VI, which is 39.75. You have a deceleration 4.5 rin dito. Pero wala kayong delta t. So you equate that and you're able to get yung delta t at 8.83 seconds. We're being asked lang naman yung final velocity just before the train starts slowing down. So we already got that at 39.75. And yung total time, you simply have to add your 15.9, 35, 8.83, and you'll get 59.73 seconds. Okay. Okay, this one is straight from your surface study. For lecture workbook, it's a different variation lang naman. The only difference is someone catches yung key mo while it's going up. So a set of keys were thrown vertically by a student from the ground. A second student catches the key 1.5 seconds later from a window 4 meters above ground. And we're being asked ano yung initial velocity ng keys? What was the launching velocity, so to speak? And what is the velocity of keys just before they were caught by the second student? So it indicates that it didn't reach yung maximum height niya because it was stopped abruptly. Hence, you still have your initial and final velocity mo dito. If it mentions na it reached yung max height niya, meaning at a certain point in time, yung final velocity mo reaches 0. Okay, but here it's just stopped abruptly, you know? So just to figure it out, you can actually go straight dive in with the equations na, pero or you can draw it figuratively. You can draw it graphically like I did here. So I know yung delta y ko is 4 meters. I know yung total duration niya is 1.5 seconds. Okay? And we're dealing with one dimension kinematic problem, pero vertically naman. So instead of A, we're dealing with G at constant acceleration. Yeah, negative G. And if you could recall, at constant acceleration, we have the formula just like so. Vf equals to Vi minus G tilde T. We also have this particular equation. Instead of X, magiging displacement, vertical displacement equals to initial displacement plus half ng ng sums ng final initial velocity times time. We have this. We don't have this. We don't, and these are unknown. We have this, and we have this. So in short, we have two equations. So we have to set them up and solve them simultaneously. So for using this naman, we have Vf, Vi, and you will end up with this equation, minus 14.7. You pause that for a while, and then you simplify this. This is just simply, this is 0, and this is simply 4. So you got that. And you have this equation here. You simplify, and you got this particular equation here. Yeah. And all you have to do is just substitute na lang. Actually, sinubstitute na pala. Ito na pala yung, this is the equation 2. And I substituted 1 dito sa, yung value ng Vf dito sa, yeah, I substituted this here. So that you have this messy equation here. You just simplified it. I just divided 1.5 by 2. So that parang single line lang tayo, walang fractions, and you would end up with this. And you just simply isolate kasi you were able to solve yung Vi naman dito, and you will get 10.02 meters per second. Once you got that, you substitute yung Vi mo with the equation 1, and you would get negative 4.68 meters per second. Okay. Usog pa lang yung buong equation na to. Okay. I think we have enough time for 2 more problems or 1 more problem. Let's try solving this naman. Yeah. I believe it's kind of tricky rin kasi you're talking with velocity vectors. It's kind of moving at the same time, so both x and y axis. Yeah. Okay. A particle is moving in an xy plane, starting from the origin with an initial velocity of x of 15 meters per second and an initial velocity of y at negative 10 meters per second. Now the object moves at constant velocity in x and constant acceleration in y. The acceleration in y is negative 1 meters per second squared. Okay, you are to determine yung velocity vector vf at any time t, and determine yung position of particle r at any time t. And then, of course, what is the position of the particle after 5 seconds and later? For problems na ganito, and the way review ko rin yung lecture work mo, it's really tedious rin, and it didn't exactly provide proper explanation lang naman dun. Pero if it's these steps naman are very clear naman dun when solving it. It's similar to your vector analysis lang naman. It's just that you're dealing with particles moving in the xy plane simultaneously. The best way you can actually deal with this is just provide mo na yung given. you know that you have yung designation pala ng I or J dito is just indicated that this I is yung yung X components yung dito, and J is yung Y component. It's a designation lang naman din eh. It's a unitless dimension eh, so to speak. So I think we define it based on the nomenclature ng book. We have here a initial velocity of X ng 15 meters per second. We have yung initial velocity of Y ng negative 10 meters per second. We're here to determine any time t, so we assume we are given an ay at negative 1 meters per second squared. For ax, I think we're not given anything, so 0. So meaning we are at a constant. Constant v, unless otherwise specified. Pero it's already stated here. That's our clue. Na 0 acceleration siya kasi constant velocity x niya. Okay. Wait lang. Mas maganda kung different color siya. Yeah. Okay. Now that we have yung given natin, let's try one by one to find yung A, velocity vector. B, yung particle r with respect to time. And C, yung position niya essentially at time t. At t equals 5 seconds. Yeah. So there we go. Solution for A. Kindly recall yung equation nun na yung vector niya is kind of like so. I think ito yung x and y components mo. So all vxi plus ax times t. Very familiar yung formula at constant v naman. And then we put yung I here indicating in yung x components. And then here the other side is yung y component. So, yeah. At first, medyo intimidating kasi it has weird symbols. Pero once you know yung idea and concept behind the equation, it's actually quite simple kasi you're dealing with constant velocity and a particular acceleration naman dito. But you're simply playing with the given that you have rin naman eh. And the answers here are usually given in a equation form kasi the problem is asking just for an algorithm so that at any time t you do know yung velocity vector kaagad, and velocity vector is really important for objects traveling in multiple dimensions at the same time, aka a rocket, a satellite, or even an airplane if you're planning to be a pilot. And that would be cool if some of you have plans to become a pilot after college, right? So go for it. I suggest you take the military route para bayad ka agad yung flight lessons nyo and flight hours, with the major cons of serving the military nga lang naman if that's your thing. But at least yung cost is good na once you get accepted. Okay, anyway, so you have that, and you also have yung isang particle rin, basically yung position to. So it's just simply that plus yung positions ng y. Oops, mali. And this is J. Okay. This one is yung position niya relative yung change of the X and Y displacements rin. Eh. So with that, using yung equations na to, we set up yung equations 1 natin by simply substituting yung values natin. So let's just use yung 1. Copy lang natin dito ulit para pakita ko siya ulit. And then we substitute. So we have 15, I believe so. We are constant velocity, so yung acceleration natin is 0. We have time. Do we have time? No, it's just time t at any time t daw. Eh. So we just represent it in terms of t. And then VYI, we have VYI, right? So that's negative 10. We have plus negative 1 meters per second squared in terms of t, and then J. I believe we simplify equation ito, combined terms. We simply have 15. Yeah, there we go. If I hopefully you got that. The next one naman is in terms of RF. So I think we just simply substitute lang naman and express it in T. So once we got that, we can now solve for the position niya, initial ask. We just write down again yung displacement vector na to. Yeah. Okay. We know that, recall that XF is VXI T plus AXT squared over 2 based on your kinematic equation. So you can actually solve for that. We have VXI na dito, which is at 15. In terms of T, this is essentially 0 kasi 0 to. So cancelled na yan. So XF mo is just simply 15T. And then you have yung YF mo. Pangit. Dapat talaga inayos ko na nandito to. There we go. Which is VYI naman plus AYT squared over 2. And you know that we have VYI, which is what, negative 10, I believe. Wait, I forgot the T. Yeah, VY is negative 10. t plus -1 t squared over 2. And yeah, factoring out yung negative thing na yun, you got -10 t plus t squared, I believe, over 2. So you got that. And now you simply just substitute it here. That is your final answer then. Which actually set us for another equations naman this, since you already have this one and we're being asked naman yung third one, additional bonus question na what's the position of the particle after 5 seconds. So pag ganon, you simply just to substitute lang naman yung 5 seconds from the solved equation that you had before. In this case, yung equation and yung resultant yung position of the particle at xt at time t pala. In fact, you can also use equation mo for velocity vector to solve yung time t rin. What is the position and direction of the particle naman eh. Okay, so using lang this person, so wait lang. This will be my final problem na lang siguro. I'll show you the rest na lang later. The time t at 5 seconds. You have this equation na magiging 15 times 5 vertical, and then this one will become 10, 5. You simplify that, you would get I believe 16.5. Okay. And here, you know now yung displacement nyo at the x and y, no? So you have this and this. Essentially, you had your xf nyo at 75 meters and yung vertical displacement mo at negative 62.5 meters. And from there, it just simply trigonometry na lang. So you get your 75 square dito plus negative 62.5 square. And I believe you would get the answer ng 97.63 meters. So that's your first answer. Ask dun kung magnitude niya. And at what particular direction, you simply just get the tangent inverse lang ng dalawa. Okay. You can also use nga yung velocity vector and time 5 din naman. You just substitute lang naman. So you're just gonna use equation na to and just substitute yung time t, and then you will get yung vxf and vxy nyo eventually doon. Then you just simply, get yung tangent inverse na yun, and you would get rin at negative 45 degrees. if velocity vector yung pinapahanap naman at after time 5 seconds naman. Okay? In this case kasi it's displacement eh. Sige. I'm just gonna stop there na lang muna and oh no. See. Okay, there we go. So we got two more equations dito. Hopefully ma-solve ko after ng second and last class ko mamaya. Any questions? None? Okay, so we are in perfect attendance pala. Okay. Sige.